CNN International plans to bring you live coverage of the launch of Shuttle Endeavour a little later on Thursday. CNN's John Holloman has a preview of the shuttle mission.
The Space Shuttle Endeavour is poised for a dawn launch, which could answer some big questions about the Earth's environment. After a series of minor equipment problems and worry about the weather in Florida, shuttle managers say they expect to launch on schedule.
The vehicle is, as Bob will tell you, is in good shape. We're ready to go fly. We're ready to support our international and American compatriots in this endeavor, and we look forward to doing just that.
Looking from the tail of
the main payload in the cargo bay is the Space Radar Laboratory. Back in April, it made dramatic pictures of the Earth's surface using radar imagery to look beneath clouds and under desert sands. Scientists hope to compare what humans are doing to the Earth's environment and what nature is doing to the planet. The idea behind sending the same payload into orbit 4 months apart is to examine the Earth in spring and summer with the same instrument. Astronaut Tom Jones is making history by flying on both missions. He's the first American to make 2 launches this close together, and he hasn't had a day off in a year.
So I look forward to the chance to benefit from what we learned and saw on the first flight, but I'll also look forward to a vacation after this one's over. And I think I'll particularly savor the chance to reflect on the mission after we complete it, because
there's a concrete mixer aboard to make the first concrete block in space and a container filled with 500,000 U.S. Express mail stamps. The stamps, which commemorate the Apollo 11 moon landing, will be moving at express speeds in space. After launch, they'll travel at 17,500 miles an hour. John Holloman, CNN reporting. Stuart, good morning. The shuttle countdown clock ticking in the final moments of Endeavour's countdown. Now the 6-man crew is strapped in, ready to begin its 10-day Earth observation mission. The main goal to use a space-based radar system to look at most of the Earth's surface and study environmental damage, including hurricanes and fires. CNN's live coverage will continue in just a few minutes. Launch is scheduled for 6:54. Stuart, I hope you'll be watching. Should be quite a show.
And thanks very much for an update on that space shuttle launch. John.
Stuart, the countdown clock is in its final few seconds before the launch of Shuttle Endeavour. We're less than 2 minutes away from launch right now. The 6-man crew is going to spend 10 days in space using a high-tech space radar system similar to the one used for years on spy satellites to monitor environmental changes on the Earth's surface. NASA commentator Bruce Buckingham is the other voice you'll be hearing until liftoff. You see there, about 1:39 seconds before liftoff. This launch, by the way, could be visible for several hundred miles up the east coast of the United States. The shuttle will be traveling north-northeast rather than due east to reach an orbit which can see 95% of the Earth's surface. It has to go north on takeoff in order to get that close to the North Pole so that all of its following orbits will cover so much of the Earth's surface. By evening today, the astronauts will have the space radar operating, sending us the first pictures of the hurricanes around the world, the western United States brush fires, and environmental changes all over the world. German and Italian scientists have developed equipment for the shuttle radar lab, and there are observation sites all over the world. About 2,000 ground-based observers are going to confirm the information coming down from space. For our international viewers, you can stand by for more programming after this. We'll have some word for you on the latest on the labor crackdown in Nigeria. But before we do that, we will, of course, show you this launch, so stay with us for that. In the final 30 seconds, we'll listen to Bruce Buckingham as he comments on the shuttle's liftoff.
When we have a go for auto sequence start, Endeavour's onboard computers have primary control of all the vehicle's critical functions. T-minus 20. T-minus 15 seconds. 12, 11, 10, 9, 8, 7. We have a go for main engine start. We have 3 main engines running. 3, 2, 1, and have main engine cut off. GLS safing is in progress.
Path 101, DFS moted to 102, LDB shows 1. Copy, launch team, that's page 909.
We have a cutoff of the main engines. The countdown clock has stopped.
CDR, perform DFS safety.
We've got a problem with the Shuttle Endeavour out on launch pad 39A. What happened was that the main engine shut down at about half a second before the solid rocket boosters were scheduled to be ignited. You can see now they're putting the white room back over next to the door so the astronauts can get out of there.
Water is on. Go ahead, CDR. UFO spacing is complete. JBFX, have you terminated your launch cooling spray? PLT, perform APU shutdown.
This is bad news. It is probably not dangerous news, but it's bad news for the shuttle program. Let me give you some background that I got from a NASA manager about an hour ago. He said that it was unlikely that they were going to have a problem like this, but the fact is...
NPL, fire and leak detectors. F31.
We look good, on green.
Copy.
The fact is there have been technical problems with this shuttle more than on any of the previous 3 or 4 shuttle missions that have had to be solved by ground controllers and the engineers going inside the shuttle over the past couple of days. The NASA mission manager that I talked to about an hour ago suggested to me that if this particular scenario occurred, where they had the main engines fired and now, as you can see, they're filling them with water, it could well be 2 weeks before this shuttle could take off. We won't know that for certain until they've assessed the damage to the main engines, which were very, very hot just about 60 seconds ago and are now getting cold and wet from this water deluge that is cooling them down, so the shuttle will be safe.
Computers has occurred unscheduled. Everything appears to be safe with the crew.
935, ISL. ISL verified. DPS?
DPS verified.
CCME? CCME verified. CSME?
Since the Challenger disaster back in 1986, this is the most serious safety problem that's ever occurred with a shuttle.
Verifies 910. CLOX? CLOX verifies 11 and 12. HTD? HTD verifies 13 and 14. CGSF? CGSF verifies 15. APU?
APU verifies 16.
CBHY? CBHY verifies 17. EPD? EPD verifies 18 and 19.
You can hear people verifying numbers, which started at 1 and are now up to 18, 19, or 20. These are emergency safety procedures on a checklist that are being completed by on the shuttle itself by the crew and by ground managers as they go through these procedures.
Checks. Everything continues in order after this unscheduled cutoff of our main engines, just milliseconds prior to liftoff.
Up on step 22, CDR OTC, reconfigure heater.
Roger. Heater reconfig is inward.
Copy.
There are more than 400 switches inside the shuttle cockpit that the pilot and the commander are now having to put in a safe position rather than a launch position, and they have to verify this with controllers on the ground.
Flight controller power switch off.
What they're doing is shutting down electrical systems on board one by one so that there could be no spark, which could potentially create trouble later.
Fuel cell 1, 2, and 3 switches, all 3 off.
They're going down a circuit breaker panel now, cutting off the various power sources to various parts of the shuttle orbiter.
That's complete. Copy. Panel F8, the flight controller power switch off.
That's complete.
CGSS OTC verify OAA is extended, locked, and configured for retract. CGSS can verify. NOTC, GLS can configure, we're configured for PCMMU to remote. Okay, CDR panel C3.
What has to happen before the crew gets out of the shuttle? Just a minute, we'll listen to NASA commentator Bruce Buckingham.
The data that's coming in from the onboard computers, as well as the data that's being assessed by the consoles here in the firing room.
NOTC, GLS primary taping is complete, or go for transition to T9. Houston flight into.
In order for the crew to get out of there, all these switches that the crew controls inside have to be put in the safe position.
What caused the engine shut off. We anticipate that the crew will shortly begin their egress procedures to leave the vehicle.
F33, verify configured for G1 to G9. CMPL.
CMPL's ready.
C-lock.
The way the shuttle is set up, it is a 2-level flight deck. You have the people who drive the thing, the commander and the pilot, and one other crew member on the upper level where the windows are so that they can look out. The other 3 crew members are down below them. And the The way you get out of there is through that hatch on the side, and in general, people come out in the opposite order of the way they get in. So the payload specialists, the ones on the lower level, would almost certainly be the first ones to come out. But inside the shuttle orbiter right now, there is an abnormal for the Earth atmospheric pressure. They sort of pump it up like a balloon to have it at flight pressure. And they're going to have to open the hatch to release that pressure before they can come out.
On the engines, no indication of fire. We'd like to shut off the heat fuel water. Okay, you've got to go, Steve. Thank you, sir. Okay, I copy. CCMA.
At any rate, this problem with this launch of the shuttle is going to cause NASA to have to crunch its schedule a little bit. It was expected that on the 9th of September, another shuttle would be leaving from Launch Pad 39B at Cape Canaveral, the Kennedy Space Center. That will probably now have to be delayed because NASA is not able at this moment to keep two shuttles in space at the same time. They only have one operating control room, and you have to have two to have two shuttles in orbit. They've never done that before. They certainly may have this mission and the next mission going up at close to the same time, however, with only a couple of days between.
TBC verifies 249. Copy, TBC.
The preliminary assessment is that we had a problem with our main engine number 3 high-pressure oxidizer turbopump. We are still continuing to assess the data as it arrives in the firing room.
In case you missed that, the shuttle was scheduled to lift off about 6 minutes ago. The three main engines had been brought up to full power, or almost full power. With less than a second to go before the shuttle was to leave the pad, the computer shut down all three main engines. There was a lot of black smoke coming out of there, which was expectable. And let me show you the video of what that looked like about 6 minutes ago as the launch was down in the last final seconds. We'll just watch it. You can listen to the commentary at the time, and I'll tell you what I know about what has happened.
We have three main engines running. 3, 2, 1. And have main engine cut off? GLS safing is in progress.
Path 101, GFS motor to 102, LDP
Very
post 1.
surprising event there.
LDP, perform RSS board, GLS post is in progress. Copy, launch team, that's page 909.
We have a cutoff of the main engines. The countdown clock has stopped.
An unusual happening. This has happened once or twice before in the history of the shuttle program. What happens is that there is an onboard computer that tests all three of the main engines in the last 5 seconds before liftoff. Main engine 1 came on, operated correctly. Main engine 2 came on, operated correctly. Main engine number 3 came on and was beginning to operate correctly when a sensor that was connected to the computer sensed that one of two very fast-turning pumps called turbo pumps was operating in an incorrect way. It was not putting enough liquid oxygen down into that engine's firing chamber to create the right amount of thrust. So the computer said, okay, we're shutting everything off before the solid rocket motors, which can't be shut off, were ignited.
OTC, MTSU, and config complete.
Okay, I copy that. NT. Standby 1.
What we've been told is that the 6 crew members will be allowed to get out of the shuttle as soon as all the configuration checks, in other words, all the switches are put in the right aspect.
Situation with the main engine number 3, the high-pressure oxidizer turbopump. The specifics are still unclear. That information is coming into the firing room, and we anticipate to have that information available shortly.
Let me tell you a little bit while we wait for more information on this, how the shuttle propulsion system works. You see those 3 big engines there at the bottom of the space shuttle. They provide the main power to get the shuttle into orbit. You can see steam coming out of one, the one that was closest to the camera there a minute ago. Those 3 engines operate through a mixture of liquid hydrogen and liquid oxygen. They join together down there in that chamber that you saw. They're ignited by an electrical spark. They explode, and that provides most of the power for the shuttle.
There is no indication of any hazardous vapors or any flammable situation at the pad. The crew is reporting safe. The vehicle is reporting safe.
In the original design of the space shuttle, it was going to try to get into orbit with only those 3 engines because they're so easy to control. You can turn a knob and increase the flow of
just
liquid
to recap,
oxygen and hydrogen. We'll
we
listen
did
to
have a
the
main engine
recap
shut
again
off
here.
just milliseconds prior to solid rocket booster ignition. This shut-off was caused by the ground launch sequencer cutting off as a result of apparent misinformation being received from one of thousands of sources of information. In this particular case, the data seems to be coming from the main engine number 3 high-pressure oxidizer turbo pump, that something went wrong within that turbo pump. We're not sure exactly what, but it did cause the main engines to cut off.
We'll check with EPD.
At any rate, these main engines are very complicated pieces of equipment. Rather than just having the liquid oxygen and liquid hydrogen flow together in the combustion chamber, they have to be forced together at a very high rate of speed. So NASA made a decision to put in turbo pumps that increase the force and the pressure on the liquid oxygen and liquid hydrogen stored in that huge red tank there to make the shuttle lift off and to force the initial ignition of those engines. And what we're going to do now is take a brief break, but what we'll do is we'll continue to stay here. I'll continue to monitor this. As soon as the astronauts begin to come out, I imagine we'll be able to show you those pictures, and we'll let you know that they are safe as soon as we know that for ourselves for sure. So we urge you to stay tuned to CNN and CNN International, because we'll continue our coverage of this situation, which was potentially dangerous, and I won't be satisfied until we see those astronauts out there and away from Launch Pad 39A. CNN's news will continue in just a moment. Stay with us.
LTC's sequence 30.
Go for main engine start. We have 3 main engines running. 3, 2, 1, and have main engine cut off. GLS safing is in progress.
As you can see there, the shuttle's main engines ignited right on schedule, but the spacecraft's computers shut down the launch just milliseconds before the auxiliary rocket boosters were set to fire. NASA says the crew is safe, but this may have been the closest a crew has come to danger since the Challenger spacecraft blew up shortly after takeoff. The spacecraft is carrying a very sophisticated radar laboratory. It is designed to monitor planet Earth. The same radar lab flew aboard just a few months ago. The images from both missions were to be compared in an attempt to understand how the Earth changes from season to season. There is no word at this time as to why the engine shut down. NASA sources tell CNN it could be 2 weeks before NASA tries to launch Endeavour again. A Japanese attempt at a space launch also fizzled Thursday when 2 rocket boosters attached to the spacecraft's engine failed to ignite. Everything in the countdown was normal up until the time the rockets were supposed to fire. This was the first attempt to launch a large-scale satellite into orbit, relying solely on Japanese technology. Both the rocket's main engine, which did work, and the boosters were made in Japan.
You are looking at a live shot of the Space Shuttle launch facility in Florida. About 6:54 a.m. Eastern Time this morning, the Space Shuttle Endeavour was supposed to take off. It did not. There was a main engine failure at the very last second. The astronauts are safe and still inside the launch vehicle. They'll be coming out in about 10 to 15 minutes' time, and we will be covering that event live. Good morning, everyone, and welcome to Business Day.
Stuart, after what seemed to be an interminable delay, the ground crew members are back out at Launch Pad 39A. You can see them there. They've just put a protective shroud around their the White Room area, and they're about to open that hatch and let the astronauts come out.
Management team Lauren Shriver and a representative of the main engines and the Marshall Space Flight Center to be there to discuss the cutoff abort this morning.
Bruce Buckingham announcing that NASA is going to have a news conference in a few minutes.
Going to have to be looked at very closely. In situations like this, we normally replace the 3 main engines before we allow Endeavour to fly. That could put us down a couple of weeks at least before the vehicle is going to be ready to go. The history of main engine cutoffs, this is the 5th main engine cutoff that we've had in the history of space shuttle flight. We had one main engine cutoff in 1984 that was on mission 41D. We had one in 1985 on mission 51F. And we had 2 main engine cutoffs last year on STS-51 and STS-55.
Okay, how about steps 28 through 30?
Again, at 6:54 a.m. this morning, the 3 shuttle main engines were commanded to halt by the ground launch sequencer. And the onboard computers of the Space Shuttle Endeavour.
Complete.
Safing has been initialized and is now in the process of being completed. And the crew, the 6-member astronaut crew, are just moments away from having the hatch opened and having them egress the vehicle and make their way back to their crew quarters at the operations and checkout building.
242.
A press conference again. A press conference is scheduled for 11 o'clock a.m. Eastern Time from the Kennedy Space Center to discuss this situation.
Okay, stand by.
So you see now the live picture of ground crew members unbolting bolts that keep the hatch of the shuttle, that keep the hatch closed.
Let me know when you crack the hatch. We'll do that.
Those ground crew members, one of them now, talking to ground controllers
We have to depressurize.
back at the lunchroom. And they say it's going to take several more minutes to get the hatch opened. And if there's an open microphone out there in the White Room, you might hear the whoosh of escaping air as the hatch is opened and depressurized, because there is higher pressure inside than outside.
Is your recycle for 1004 complete?
Well, the best we can do right now, we're not in drain yet. We need to get the crew off first.
Okay, we'll wait on that one.
As you can hear, there are some technicians at NASA who want to do things other than get the astronauts out of there, but the mission managers are saying get those 6 men out of there as quickly as they possibly can. That takes precedence over anything else that they're doing right now. We might, if we can possibly do this, continue to watch as the ground crew members work on the hatch, and also show you what happened when the main engine cutoff occurred. I'm told we have a version of that where we can watch the last 60 seconds of the countdown. You'll be able to see the 3 main engines come on one by one. And
T-minus 1 minute and counting. T-minus 50 seconds and counting, and we are transferring to orbiter internal power at this time. Endeavour is now running off of its 3 onboard fuel cells. Coming up for a go for auto sequence start.
Okay, let's go for auto.
And we have a go for auto sequence start. Endeavour's onboard computers have primary control of all the vehicle's critical functions. T-minus 20. T-minus 15 seconds. 12, 11, 10, 9, 8, 7. We have a go for main engine start. We have 3 main engines running. 3, 2, 1. And have main engine cut off. GLS safing is in progress.
Path 101, DFS loaded to 102, LDB shows 1. NAP USB, 4 miles LS board. GLS is in progress. Copy, launch team, that's page 909.
We have a cutoff of the main engines. The countdown clock has stopped.
CDR, perform DFS safing. And NTD, GLS safing is in work. Ignition septics are safe. All engines are in post-shutdown standby. GLS is go for orbiter APU shutdown.
let me explain to you what happened in this sequence of events as best we know it at this time. In order for the shuttle to leave the Earth successfully, about 1,000 events have to happen in the last 5 seconds, including a test procedure of the 3 main engines, and then the 2 solid rocket boosters are ignited to get the shuttle off the ground. The way the main engines work is that a series of pumps increase the pressure of liquid oxygen and liquid hydrogen going down into the combustion chamber. There's a low-pressure turbo pump which worked correctly for the liquid oxygen tank and got the pressure there up to about 400 pounds per square inch. And then the liquid oxygen was forced into another turbo pump, which spins at a rate of 24,000 revolutions per minute. Much faster than your record player or CD player. I mean, much, much faster. And the temperature inside there got so hot that it triggered an alarm which shut down the main engines. What we're looking at right now is the live picture. You see a huge yellow hose that's hanging down that provides outside air and exhausts what air is inside the crew cabin. Right now, the astronauts have been sitting out there for about, for more than 2 hours. There are, the temperature inside the shuttle at this point is probably out of the comfort range. They've been sitting there. The sun has been up for an hour. The air conditioning system, along with all the other electrical systems inside, has been shut down. So they're probably wet with sweat at this point as they wait to get out of there. My colleague Paul Karen joins me again live on the phone from the Kennedy Space Center. Paul, I'm sure you've been talking to the experts there. What's the latest from your end?
Well, NASA engineers have told me, John, that the problem appears to be, as you had mentioned, with the high-pressure oxidizer turbo pump on main engine number 3. Apparently, it shows two temperature channels on this pump, and one channel was high into the red zone, and another one was near that. As far as past history with these pumps, they've had problems in the past with these pumps, but in regards to seals on the pump, and NASA engineers have told me this problem today does not appear to be with the seals.
All right, Paul. I'll tell you, if I can show up on TV for just a second, I can sort of illustrate what's going on with this turbo pump, or what apparently went on with it. I may not be able to do that, but the turbo pump is this huge round object like this that spins on a channel, and these channels that they're talking about are little holes on the inner chamber with thermometers in them. There are 2 thermometers. One of them went above a degree mark that told the computer that there might be a problem, and then the other thermometer started to show the temperature go up as well, and that's when this thing was shut down. Those ground engineers right outside the hatch, the escape route for the shuttle, have just opened it.
Go ahead. Copy that. Thank you.
Normally, the crew will
the
egress
shuttle
in
crew,
the same order that they
we'll
entered the
see
vehicle.
how they're coming out.
That being the case, we should see Dan Birch coming out first.
Probably the last 2 people that we'll see coming out will be the commander and the pilot, but because they are the people who've had to do most of the work during the past 2 hours, we'll talk about them. Michael Baker was born in 1953, 4 days after my birthday, as a matter of fact, October 27th. He's from Lemoore, California. He graduated from high school there in Lemoore and got a Bachelor of Science degree from the University of Texas back in 1975. He's married, and he has 2 children, and he's an experimental test pilot and has been in the astronaut corps since 1985. And he's not that old relative to some of the astronauts, but he is the commander of this mission based on the fact that he has been on the shuttle several previous missions. Terrence Wilcutt is a major in the United States Marine Corps. He's another one born in October 1949. He's about my age, married with 2 children again. He likes to fly, he likes to run, he lifts weights, and he does woodworking. What we're looking at now on television, the ground crew members are now going inside the shuttle, providing some assistance probably to the first of the astronauts to come out. There are, in addition to the 2, the pilot and the commander who we just showed you, the payload commander is former CIA analyst Tom Jones. It may be that Tom is up on the upper deck with the pilot and commander as well. And then down below on the double-decker 2 decks of the shuttle orbiter are the 3 mission specialists. And my guess is, because the astronauts generally come out in the opposite order of the way that they went in, is that we're going to see Dan Birch, who was the last astronaut to get on board first. He's a mission specialist and has been a member of the astronaut corps for more than 5 years. One of these astronauts has only been in the astronaut corps for 2 years. Steve Smith has had a very fast tour from joining the astronaut corps to flying in space. You can see Steve there. He was in the astronaut class of 2 years ago, the first member of that class to fly, and he is flying in the space shuttle much more rapidly than other astronauts have in the past. He was at a news conference a couple of weeks ago, and he laughed about the fact that he got to go first, and he hoped it was because he was so much better than the other astronauts in that class. But these fellows, not to put too fine a point on it, but they all have terrific egos as part of what you need to have the right stuff to be in the astronaut corps. Paul, the hatch door is open now, as I see it from here, and We haven't yet seen one of the red flight suits indicating that Dan Burch or one of the other astronauts is coming out. But what are you hearing from a technical point of view about what's causing us to have this time on television together?
Well, it's still the problem, as we had mentioned earlier, with the high-pressure oxidizer turbo pump on main engine number 3. And now one of the questions, of course, that lingers, John, as you know, is how long will the delay of the Space Shuttle Endeavour liftoff actually happen now?
Yeah, well, one of the things that they said they would probably have to do, almost certainly have to do, is go out to the launch pad and pull all 3 main engines off the bottom of this space shuttle. A very time-consuming and painstaking procedure. It's not like taking the engine off your car, because these engines are much more fragile than automotive engines, and you can't just have a crane out there to do it. You have to do it in a very meticulous, painstaking manner. They're putting some insulation material out over the hatch now. The hatch was coated with grease before the astronauts went in, and there's
and the crew
first
members with their helmets still on are beginning
the astronauts to come out
of Endeavour. 6 astronauts will be egressing in the next few minutes.
I see Tom Jones with his helmet off. He's the second of the 2 astronauts to come out.
It looks like Peter Weissoff was the first to come out, followed by Dan Burch.
These are the astronauts who sit on the lower deck of the 2-deck shuttle orbiter flight compartment.
And CMQ-CO2C, steps 141 being not performed, 142 through 147 not performed.
The astronauts normally get in with the one on the left, the one on the right, and the one in the middle. And the way they came out was the one closest to the door first, then the one in the middle.
Go ahead.
We're likely now to see the one on the left of the bottom section coming out.
Copy that.
Astronauts appeared to be not much the worse for wear. They were smiling, although I bet to a man they would tell you they're not happy right now. See that yellow hose going inside now, providing some cooler air to the crew. The astronauts have told me when I've talked to them about sitting out there on the pad waiting to lift off, that the biggest problem they have is the temperature. The sun in Florida is beating down on the side of their shuttle orbiter. In space it's pretty cold, and they're able to maintain a temperature of about 72 degrees after they get in orbit, but before they leave they just don't have enough air conditioning to keep their bodies at a good cool temperature, and it gets up to 95, 96 degrees inside the orbiter. For the past couple of missions, the astronauts have been wearing what's called a cool suit, a series of water-cooled tubes wrapped around their bodies that provide a certain relief from this heat. But you can imagine the tension and the pressure that they have been under since 6:51, 6:54, about the past 59.5 minutes since they were expecting to be well on their way and into orbit, and they've had to sit there atop this 500,000 gallons of liquid fuel and those 2 very
Standing by
dangerous
now
solid
for
rockets.
the remaining 4 crew members to depart the Shuttle Endeavour. Just about an hour ago, we did have a main engine cutoff with the countdown clock reading T-0. However, the solid rocket boosters did not ignite. The onboard computers on Endeavour did their function well. They stopped the launch sequence from reaching its termination point of launching Endeavour with booster ignition. The computers did their job as they have been programmed to do, and that is if all of the aspects of the critical launch components on the vehicle are not in their proper order, then launch will not proceed. They are designed that way, and they perform their function as they were designed. Again, all we know at this point is that the high-pressure oxidizer turbopump discharge temperature exceeded the red line value on main engine number 3 We anticipate that it'll be a few hours before we get any more specifics as to why it exceeded the red line value. Mission managers are at this point meeting here in the Launch Control Center to further discuss it, to get more information from the engine experts, and to then follow up with a plan of action for what we will do with Endeavour and mission STS-68 from this point on.
All right, we're going to once again show you while we wait for the rest of the astronauts to come out a picture of what it looked like when the engine shut down about an hour ago.
We've had situations like this, and this has occurred 4 times before. That's 7. We have a go for main engine start. We have 3 main engines running. 3, 2, 1, and have main engine cut off. GLS safing is in progress.
Pass 101, DFS motor to 102, LDB shows 1. It is USB, 4 Mars LS4, US station is in progress. Copy, launch team.
That was at 6:54 Eastern Time about an hour ago.
The countdown clock has stopped.
CDR perform BFS safing.
B this evening. That decision, of course, will have to be made today on whether we will roll out.
That was astronaut Dan Bursch, who just got out, third of the 6 astronauts to leave.
Go first. So these are some tasks that the mission managers will be addressing over the next couple of days. Meanwhile, back on Endeavour, we do have another of our 6 astronauts has left the vehicle and will be standing by for the remaining astronauts to disembark and to then return back to their crew quarters, and then ultimately on back to the Johnson Space Center as a decision on this flight is made.
So things are in fairly significant flux down at the Kennedy Space Center and NASA headquarters, I'm sure, in Washington, and at the Johnson Space Center in Texas, as mission managers decide to do what to do next. Paul Karen, you heard what our NASA commentator Bruce Buckingham was just telling us about all this. Have you gotten any more information?
Well, we know that this is certainly going to delay things, John, as far as any upcoming launches, and that's not unprecedented. Back last year, they first tried to launch Discovery July 17th and had problems, and the delays pushed that launch all the way to September 12th. So we could possibly see quite a long delay with the Space Shuttle Endeavour here.
Paul, thanks. We've just, I believe, gotten a phone call from NASA spokesman Jeff Carr, who says that contrary to what astronauts have told me in the past, and I told you a few minutes ago, the temperature inside did not get up to any higher than a comfortable 74 degrees, which means these astronauts are, no wonder they're smiling as they come out. And I do stand corrected. The information I was giving you was based on conversations I'd had with other astronauts about what it's like to be there on the pad, and of course I haven't had a chance to talk to this crew. Anyway, 3 of the astronauts are now out, 3 more yet to leave the shuttle.
OTC Asp is on com.
In about 3 hours from right now, NASA promises that they will provide a news conference about 11 o'clock Eastern Time with mission managers, probably Launch Director Bob Seek, Mission Manager Lauren Shriver, and others to give us what they know as of 11 o'clock Eastern Time on what went wrong, what caused it, and what's next for the shuttle. Now, what we are told is that a high-speed liquid oxygen turbo pump told the shuttle's computer that there was a problem. Here comes another one of the astronauts out. I'll try to tell you who as soon as I can recognize him. That's Jeff Weissoff, I believe. Jeff now coming out. Now the commander and the pilot, the only 2 astronauts left aboard. But back to this problem that caused the shutdown, the high-pressure oxygen turbo pump, which spins at about 24,000 revolutions a minute, was telling the computer that it was getting too hot. And That's Bob Seek talking to other people down there at the Kennedy Space Center.
Okay, great.
CNN International, the world's news leader.
The U.S. Space Shuttle Endeavour came within milliseconds of launching an hour ago, but still sits on the pad.
Go for main engine start. We have 3 main engines running. 3, 2, 1. And have main engine cut off. GLS safing is in progress.
The spacecraft's 3 main engines ignited on schedule, but onboard computers sensed a problem with a fuel pump in one of the engines, and the launch was shut down at the last possible moment. It's the 5th time a shuttle's engines have shut down on the pad in 13 years of shuttle flights. Endeavour's crew of 6 is safe. They started climbing back out of the shuttle a few minutes ago. It could be at least a month before the astronauts get to try again. Their mission is to study changes in the global environment with a sophisticated radar stored in the shuttle's cargo bay. A Japanese attempt at a space launch also fizzled on Thursday when 2 booster rockets attached to the spacecraft's engine failed to ignite. Everything in the countdown was normal up until the time the boosters were supposed to fire. And this was the first attempt to launch a large-scale satellite into orbit relying solely on Japanese technology. Both the rocket's main engine, which did work, and the boosters were made in Japan. There's more world news still ahead, including South African President Nelson Mandela's address to Parliament after his first 100 days in office. Stay with us.
SRL in Florida ist heute unter dramatischen Umständen der Start der amerikanischen Raumfähre Endeavour mit 6 Astronauten an Bord abgebrochen worden. Praktisch in letzter Sekunde wurde das hocherhitzte Haupttriebwerk automatisch abgeschaltet. Im Falle eines Starts hätte die Fähre die Erdumlaufbahn nicht erreicht. Sie wäre zu einer Notlandung gezwungen worden.
NASA officials say the problem seems to have been a high-pressure fuel pump on one of the main engines that apparently overheated. Endeavour's commander says that although he and his crew are disappointed, they were not unduly worried when the shuttle failed to blast off.
I don't think so. I think probably the biggest feeling that I had was maybe a little bit of disappointment because we do go to a lot of effort and work and training to get launched. And of course now that's delayed and we're going to have to go back and do some more retraining. But of course right at that time, like I said in the news conference, we are trained for this contingency, and as soon as that happens, we're ready to start with our safing procedures, pad abort procedures, and prepare to get out of the vehicle.
And Baker and the other 5 astronauts remained in the shuttle for nearly an hour after the aborted launch. They emerged only after ground crews determined that the conditions at the launch pad were safe. NASA officials suggest that Thursday's glitch could delay Endeavour's science mission by at least 2 weeks.
Sekundenbruchteile vor dem Abheben der US-Raumfähre Endeavour hat ein Bordcomputer den Start verhindert. Der Countdown war fast abgelaufen, der große Sekundenanzeiger schon auf 0 gesprungen. Im allerletzten Moment schaltete das heiß gelaufene Haupttriebwerk automatisch ab und wurde sofort mit Wasser gekühlt. Grund für den Abbruch war ein Treibstoffproblem im 3. Triebwerk. Erst nach einer Stunde durften die Astronauten das Shuttle verlassen. Ein neuer Startversuch ist wahrscheinlich erst in 1 oder 2 Wochen möglich.
Scientists are wondering what kind of experiments they can devise to solve a puzzling mystery. New satellite images of Australia reveal strange lines. Scientists are stumped, but they know this. Because the images were gathered by an infrared camera, which records changes in temperature, the lines are slightly cooler than land surrounding them. But they say no known geologic features, such as earthquake faults, match up with the strange lines.
It could be that there's moisture in the soil. It could be that there's some vegetation. It could be that the mineral structure is slightly different. But nobody has noticed these before in the daytime imagery.
The desolate area has not been explored much, at least not by humans. This may sound slightly reminiscent of those odd crop circles in Britain, with one important difference. Researchers don't think these mysterious marks are a hoax. Robotic engineers have written a new chapter in the scientific allegory of Dante's descent into the Inferno. A new and improved robot named Dante 2 journeyed deep into the Inferno, the steaming mouth of an active volcano. Dante 2 did much better than its predecessor in helping NASA learn more about exploring distant planets. But as CNN's Sonia Rusler explains, the final act in this morality play has yet to be written.
This is all that can be seen from the top of Alaska's Mount Spur, an active volcano that has erupted 3 times since 1992. The crater is considered too dangerous for human explorers. So NASA sent a robot to take a look down inside the inferno. Its name, Dante 2. The first Dante explored Mount Erebus, a volcano in Antarctica, but only made it 9 meters down before its communication lifeline broke. Designers at Carnegie Mellon University went back to work and built a new and improved cord. Dante 2 weighs in at 1,700 pounds or 750 kilograms. It plods forward about 1 centimeter per second on 2 sets of 4 legs.
It's sort of like 2 coffee tables, one sitting over top of the other. The robot sets one set of 4 legs down, then lifts up the larger set, moves that set forward, puts it down.
This robot did much better than its ancestor. It was airlifted up to Mount Spur late in July.
We're getting ready to start walking.
And then it did walk all the way to the bottom. Dante looks out through 8 video cameras and can use the information to move itself using artificial intelligence. Or it can operate under remote control by scientists who received instantaneous feedback from the robot by satellite. Everything went well until the robot turned to go home. One leg got stuck in the mud, less than 150 meters from the rim. NASA sent human volunteers down into the crater to attach a harness to the robot, and it was successfully lifted to safety. NASA sees an earthbound future for Dante, probing volcanoes when they threaten to erupt.
You could fly Dante or Dante's descendants to that volcano, put it on the crater, have it enter the crater, take science observations, and then come back out.
Working in Alaska did pose some problems NASA won't face elsewhere.
We were sort of scouting out our area. We were standing by in here and turned around, and there was a black bear chewing on the satellite feed horn, and we scared him off.
Working on other planets will pose still different problems for NASA, especially that they can't send out rescue and repair missions. Sonia Rusler, CNN, reporting.
The U.S. Space Shuttle Endeavour is now standing on the launch pad. It is now just moments away from takeoff at the Kennedy Space Center in Florida. We now join special coverage from CNN's John Holliman.
Primary control of all the vehicles.
We're about 20 seconds away from launch now, and we'll listen to NASA commentator Bruce Buckingham during the final few seconds.
15, 12, 11, 10, 9, 8, 7. We have a go for main engine start. 4, 3, 2, 1. And liftoff of the Space Shuttle Endeavour on a mission to study the Earth's ever-changing environment.
Houston now controlling.
Houston Endeavour, roll program.
Roger, roll, Endeavour. Endeavour's roll maneuver is underway. Vehicle's now in a heads-down position on course for a 57-degree, 120-nautical-mile orbit. Endeavour's engines are now throttling down as the orbiter begins to pass through the area of maximum dynamic pressure on the vehicle in the lower regions of the atmosphere. Endeavour's altitude is already at 20,000 feet. The relative velocity is 1,000 feet per second, or approaching 1,000 miles per hour. Endeavour, go at throttle up.
Roger, go at throttle up.
All 3 liquid-fueled engines are back at full throttle. Engines are performing at full throttle. The auxiliary power units providing hydraulic power, all functioning well, as are the 3 fuel cells providing electrical power to the vehicle. Endeavour is altitude is 85,000 feet, downrange from the launch site. 30 nautical miles. Approaching 2 minutes into the flight, the next event is burnout and separation of the solid rocket boosters.
They're breathing a sigh of relief aboard the Shuttle Endeavour right now. The solid rocket boosters are now separated. As you can see, the shuttle is traveling up the east coast of the United States in order to reach an orbit as close as possible to the North Pole. This allows the Space Radar Lab, which is back in the cargo bay, to see almost all the Earth's surface during the 10-day trip. If you're watching our coverage in the eastern United States right now, you might want to look out the window to see if you can see the plume from the solid rockets and the main engines. If you're watching in Europe, you would want to look to the west. The big goal of this mission is to use the space radar to make a three-dimensional map of the Earth. The equipment on board can measure soil moisture, can see beneath the surface of the ocean and the desert, and can look under clouds, at volcanoes, or through the mists of Rwanda at the gorillas below. Ground-based researchers hope this radar will give them a clear picture of what's under the sands in northwestern China. The goal there is to find some structures used more than 2,000 years ago by travelers on the Silk Road in China. There's some controversy about one part of the mission, too. Scientists will dump about 100 gallons of diesel fuel into the North Sea to find out if the radar can detect it from more than 100 miles up. If it can, the satellite could be used to monitor illegal dumping in the world's oceans. The German scientists who plan to dump this oil say they'll clean it up as soon as the test is completed. Now, if you were with us a couple of minutes ago at the launch of Endeavour, you saw a camera angle that I have never seen before on a shuttle launch. It's a camera placed right outside the crew's window. We're going to go there and look again at the final few seconds of Endeavour's launch this morning. Well, there you see it. The Space Shuttle Endeavour making its way into orbit more than 100 miles above the Earth. This mission will last for 10 days and will have projects provided by scientists from Japan, from Germany, from Europe, and there'll be ground-based observers all over the world helping the crew in their Space Radar Lab. John Holloman, CNN reporting.
Thanks very much, John, for that live report on the launch of the Space Shuttle Endeavour.
And liftoff of the Space Shuttle Endeavour on a mission to study the Earth's ever-changing environment.
Well, delayed for 6 weeks because of an engine fizzle on the launch pad once, the Space Shuttle Endeavour's mission is well underway now. For 10 days, its 6-member crew will measure and photograph some 20 spots on the Earth, same places that Endeavour's April mission had surveyed. Then, by comparing the pictures from the two missions, scientists are hoping to spot any subtle seasonal changes in nature. Today's liftoff meant that NASA has hit its goal: 8 shuttle launches in the United States government's 1994 fiscal year, which in fact ended this very day.
Raumfähre Endeavour ist in Cape Canaveral zu einem 10-tägigen Flug ins All gestartet. Pünktlich um 12:16 Uhr hob die Fähre mit 6 Astronauten an Bord ab. Ursprünglich war der Start für den 18. August vorgesehen. Er musste jedoch 2 Sekunden vor dem Abheben wegen eines technischen Fehlers abgebrochen werden. Mit der Radarstation XSAR, die von Deutschland mitentwickelt wurde, sollen die Astronauten Umweltprobleme untersuchen.
Satelliten liefern zwar atemberaubende Bilder der Erde, doch entscheidende Informationen über den ökologischen Zustand unseres Planeten bleiben meist unter Wolken verborgen. Diese Lücke in der Erdbeobachtung soll IXAR schließen, ein in Deutschland und Italien gebautes Fernerkundungsradar. IXAR tastet die Erde in 30 bis 50 Kilometer breiten Streifen ab. Die Radarwellen können sogar ein paar Zentimeter tief in den Boden eindringen. Im April war IXAR zum ersten Mal im Weltraum. Dabei gelangen Aufnahmen, die die Wissenschaftler mit dem Quantensprung von der Schwarz-Weiß zur Farbfotografie vergleichen. Die Radarwellen können unterscheiden zwischen Bäumen, Blättern und Gräsern. Aus 300 Kilometer Höhe ergibt sich so ein detailliertes Bild der Biomasse ganzer Landstriche. Man kann zum Beispiel aus den Daten vom April und denen von dieser Mission berechnen, wie sich die Eismassen an den Polen verändert haben oder wie weit die Rodung des tropischen Regenwaldes fortgeschritten ist. Das ehrgeizige Ziel der federführenden deutschen Forschungsanstalt für Luft- und Raumfahrt ist es, mit dem Radarauge die Basis zu schaffen für eine regelmäßige und globale Überwachung des Klimas. Diese neue Form der Umweltüberwachung kann zwar das Klima nicht verbessern, sie sorgt aber dafür, dass es Politiker zunehmend schwerer haben mit ihren Ausreden zum ökologischen Zustand der Erde.
Heute mit 6 Astronauten an Bord zu einer 10-tägigen Erderkundungsreise gestartet. Hauptaufgabe der Besatzung wird die Untersuchung der Erde und ihrer Umweltbedingungen mit einem Radargerät sein. Die Anlage ist eine Gemeinschaftsentwicklung der Italiener, Amerikaner und Deutschen.
Shuttle Endeavour has been in orbit only one day and already is sending back spectacular pictures. Astronauts flipped on their powerful radar equipment shortly after liftoff Friday, and this is what they saw: an active volcano in Kamchatka, Russia. Scientists estimate the smoke plume extends some 12,000 meters into the air.
Saturday, they recorded data on an ancient riverbed now buried beneath the sands of the Sahara Desert. The river once ran west of the present location of the Nile River. Astronauts will take thousands of pictures of the Earth during the shuttle's 10-day mission. They will use the images to study environmental changes caused by both natural and man-made activities. The shuttle crew also got an excellent view of a volcano that has just erupted on the Kamchatka Peninsula in far eastern Russia. The Russian Ministry for Emergency Situations says the volcano does not endanger any towns in the sparsely populated area, but the ministry says that its ash plume could hamper air travel between North America and Asia.
Diese spektakulären Aufnahmen wurden von der amerikanischen Raumfähre Endeavour zur Erde gesendet. Von der Eruption wurden keine Menschen auf der dünn besiedelten Halbinsel gefährdet. Auch die erwarteten Schlammlawinen stellen für die in 10 Kilometer Entfernung gelegenen nächsten Orte keine unmittelbare Gefahr dar.
Im Bild Umweltveränderungen auf der Erde untersuchen. Spektakuläre Bilder gelangen ihnen von einem Vulkanausbruch auf der russischen Halbinsel Kamtschatka. Bis zu 20 Kilometer hoch wurde Asche in die Atmosphäre geschleudert. Dadurch wird der Flugverkehr zwischen Russland und Nordamerika behindert.
Aus dem All bot sich ihnen ein eindrucksvoller Blick auf einen feuer- und rauchspeienden Vulkan auf der russischen Halbinsel Kamtschatka. Eine mehr als 10.000 Meter hohe Aschewolke ist über dem Gebiet auszumachen. Kurz nach Erreichen der Umlaufbahn konnte Shuttle-Kommandant Baker die Treibstofftanks abstoßen. Während der 10-tägigen Mission werden die Astronauten spektakuläre Radarexperimente starten. So können sie mit einem Superradar 4 Meter tief in den Wüstensand gucken, um nach Flussbetten zu suchen, die vor Tausenden von Jahren zugeweht wurden.
A volcano in the far eastern Russian province of Kamchatka has roared to life. The eruption began late Friday, the first since 1945. The US Space Shuttle Endeavour took these pictures of the eruption. The volcano isn't threatening any towns in the sparsely populated Kamchatka, but the Itatas news agency reports it could threaten airplanes between North America and Asia.
Ein Vulkanausbruch auf der fernöstlichen russischen Halbinsel Kamtschatka beeinträchtigt stark den Flugverkehr zwischen Asien und Nordamerika. Die großen Rauchwolken können deutlich aus dem Space Shuttle Endeavour beobachtet werden. Bis zu 20 Kilometer hoch soll die Asche geschleudert worden sein. Der höchste Vulkan Eurasiens ist zuletzt 1945 ausgebrochen.
Die Endeavour lieferte außerdem dreidimensionale Aufnahmen von der Sahara, dem Meer am Südpol und den südamerikanischen Anden. Bisher verlief der Flug der Raumfähre absolut problemlos.
Erst gestern war die Endeavour zu einer 10-tägigen Mission zur Erforschung der Erde gestartet. Mit an Bord ist auch ein in Bayern entwickeltes Radar, das Daten über die fortschreitende Umweltverschmutzung erfassen soll.
Die amerikanischen Raumfähre Endeavour haben kurz nach ihrem reibungslosen Start gestern die ersten Fernsehbilder zur Erde geschickt. Deutlich zu erkennen, ein abgesprengter Treibstofftank, der inzwischen in der Erdatmosphäre verglüht ist. Die Astronauten filmten auch den Ausbruch eines Vulkans auf der russischen Halbinsel Kamtschatka. Der 4.750 Meter hohe Vulkan im fernen Osten ist gestern Nacht wieder aktiv geworden. Zuletzt war er 1945 und davor 1737 ausgebrochen.
Die Raumfähre Endeavour nach einem Bilderbuchstart im All. An Bord eine der modernsten Radaranlagen der Welt. Die 6 Astronauten arbeiten schichtweise rund um die Uhr. Die ersten Bilder, die jetzt die Erde erreichten. Ein Vulkanausbruch an der östlichsten Küste Russlands auf der Halbinsel Kamtschatka. So heftig, dass die Asche bis zu 20.000 Meter hoch geschleudert wurde. Dicke Rauchwolken bewegen sich in die Atmosphäre. Ein eindrucksvolles Bild und ein vielversprechender Auftakt für die 10-tägige Mission des Space Shuttles.
Well, the US Space Shuttle Endeavour are working around the clock in two alternating teams. They are using a three-dimensional radar device to scan the surface and subsurface of the Earth.
Copy that, Endeavour.
The $366 million machine is the most powerful civilian radar ever to fly in space. It's being used to map and study areas like the Sahara Desert and the Andes Mountains. Surveys of nearly 600 sites are planned during the 10-day mission.
To predict the future. They're using radar to look for ancient river channels buried in the Sahara Desert. They're also taking pictures of active volcanoes, which scientists hope will help them predict volcanic eruptions and earthquakes.
The 6 U.S. astronauts aboard the Space Shuttle Endeavour, they're getting a very rare view of a cataclysmic phenomenon, giving scientists an unparalleled opportunity for research, giving the rest of us a spectacular show. CNN's John Holloman has details of the mission.
An erupting volcano provides great pictures for a cameraman 120 miles up in space. And that's the first major find for the crew of Shuttle Endeavour. This volcano, known as Kluchevskoy, started erupting Friday afternoon and has continued to send lava flows down its slopes. The volcano is on Russia's Kamchatka Peninsula.
Okay, Houston, you should be getting this view of the Kluchevskoy volcano. You can see the snow-capped upper slopes, and then there's a very active eruption going on from the northeast portion of the mountain. Bezyemny is behind the smoke plume. Looks like from the shadow height, you can even estimate the height of the eruption plume, but we're guessing at least 35 or 40,000 feet. And that dark gray dust plume goes downwind at least 500 kilometers, if not more.
Ground-based scientists say this volcano is very important.
Because of the importance to global change and the importance to human life and natural hazards, the Kamchatka volcanoes are important.
On the shuttle flight deck, mission specialist Jeff Weissoff and Commander Mike Baker have been working out to stay in shape, but they're also monitoring some unusual smears on the front windshield of the spaceship. Shortly after takeoff yesterday, Commander Baker reported something on the front windows that looked like bug droppings. Today, he and ground controllers talked about the possibility that the shuttle hit something on the way into orbit.
Higgs, can you see anything out over the nose or any other points of contact? Do you feel this is the primary contact?
The Space Radar Lab back in the cargo bay is working around the clock along with 2 teams of astronauts who operate it. The pictures the radar can provide are turned into 3-dimensional views by computers on the ground. This is what the radar saw as it looked at Death Valley in California on its last mission. By the time the astronauts return to Earth in mid-October, they hope to have pictures this good of much of the planet's surface. John Holloman, CNN reporting.
Meantime, the view out the window may not be as clear as it could be. Apparently, windshield splatters happen in space just like they do on the road. Didn't know they had bugs out there, though. Speaking of travel hazards, a hailstorm in and around the U.S. city of Denver shattered the windshield of a small passenger plane. Both the pilot and co-pilot were injured, but they did manage to land the plane safely. To give you an idea of the size of the hail, we take you to the center of the storm.
You couldn't see it coming. The rain was too heavy. You could hear it, though. So much for the new truck.
Man, that's a lot of hail.
I think we better get out of here.
Just hitting constantly and hard. Inside, the entire house literally shook. It was almost as though someone had put a tow trailer on the front and started moving it. It was shaking violently. It sounded like we were being pelted with rocks. It was literally, it was just like there was an avalanche hitting the house. We have a lot of rippling on this car that is all hail damage and across the roof. The back window has been completely put out. You can see at this point they've been melting for a couple of hours. But at the time they were hitting, they were literally the size of Major League Baseballs. This amazed me. This amazed me. It had to be coming down really hard to put holes through a Rubbermaid trash lid. Had to be coming down very hard indeed to do that. These things are meant to give, and they obviously were coming fast and hard to put holes through something like that. Hail particles were hitting hard enough that they went right through the aluminum. As you look up there, you can actually see ice particles hanging through the broken aluminum right about there. It had to have been hitting like bullets to go through an aluminum awning. That's how hard it was hitting, and that's one of the reasons I was extremely concerned being inside.
The scene in and around Denver, Colorado. Now,
well, John, obviously we have a much bigger view of the whole thing, and for me in particular, the East Coast, having grown up in Norfolk, Virginia, it's great to fly over the Chesapeake Bay area. It was clear this morning, and we could see all the way from the Norfolk area up through about the Delaware Bay area. And you get a feeling for just how much difference there is in the kind of land contours. You can see the Appalachian Mountains off in the distance, and you can see sun glint in the water at certain sun angles, which will allow you to actually see water patterns. And that's one of the things that the radar is going to be interested in looking at, is to try to understand eddy currents and things of that sort in the water. And we'll be taking photos, and they'll be trying to compare that to what the radar takes.
How much time do you get to look out the window? And how much do you use cameras to take still pictures and movies as you look out the windows?
Taking pictures is actually a very important part of what we're trying to do. What this mission really is about is trying to verify that this radar can measure things on the ground that we normally have to send out ground teams to measure. Things like the amount of water in the soil, vegetation, deforestation, things of that sort.
the mission is to track the activities of at least 4 volcanoes around the world. On their last pass over Brazil, the astronauts used radar to see through the clouds and the forest cover. Part of their mission is to help make sure farmers don't destroy the rainforest. They reported that they could see extensive fires rising in Brazil, even as they were already out over the Atlantic Ocean. Pictures you're going to see now, there we have it. Forest fires raging all along the southern coast of Australia. In fact, there are more than 24 Australian files. The astronauts also scouted at least 5 forest fires burning in Siberia.
There's probably no mission more important than trying to study the effects of what's going on in our environment, because it affects everybody else, everybody on the Earth. And this is a multi-nation effort. We have about 13 countries that have investigators working on this. The hardware was built by the Americans and the Germans and the Italians, and it shows that there's a world interest, obviously, in keeping the environment safe and understanding the changes that it's going through over time.
Spectacular is how one of the Endeavour astronauts described these pictures of a volcano eruption in Russia. It erupted shortly after the Endeavour blasted into space last week. The astronaut's special Earth examining radar also took shots of Sicily's Mount Etna and Hawaiian volcanoes erupting. NASA scientists hope the 3D radar images will reveal environmental changes when compared to radar images taken from a shuttle flight in April. Final preparations are complete for a joint Russian-German mission to the Russian space station Mir. A crew of 3 is scheduled to lift off from Kazakhstan in less than 5 hours. German astronaut Ulf Hallberg is expected to stay in space about a month. The rocket was brought out to the launch pad on Sunday and is said to be all ready for takeoff.
In ihrer 10-tägigen Mission macht die Crew Aufnahmen von 600 verschiedenen Gegenden der Erde. Durch den Vergleich mit früheren Bildern wollen die Astronauten Umweltveränderungen feststellen.
Einen noch nie dagewesenen blinden Passagier melden die Astronauten der amerikanischen Raumfähre Endeavour. Eine Mücke hat sich an Bord geschmuggelt, gefunden wurde das Insekt allerdings erst beim Reinigen der Filter. Alle Experimente an Bord der Endeavour laufen nach Plan. Mit einem Radargerät werden Aufnahmen von der Erde gemacht. Sie sollen mit Bildern vorheriger Missionen verglichen werden, um so Umweltveränderungen festzustellen. Außerdem beobachtet die Endeavour-Besatzung mehrere Vulkane, wie den Ätna auf Sizilien, der seit ein paar Tagen Asche spuckt.
CNN's John Hallman joins us now to explain what it all means and what those pictures are.
They're doing some amazing things, Jonathan. The gorillas that Gary Stryker was just showing us pictures of are being mapped by the space radar. The Endeavour astronauts trying to help track that earthquake in Japan and the tsunami tidal wave as well. And we've got some pictures that were taken about an hour ago, and while you can see lightning in the Pacific, the shuttle was too far away to see the island of Japan. We're told a little bit later today we'll get better pictures. Endeavour will be flying over Japan in about an hour, may be able to take some pictures of the earthquake and its aftermath. So far today, they've aimed their space radar at the Pacific coast of Canada, the Sahara Desert in Africa. Astronaut Tom Jones is in command of the radar.
The beauty of the radar system is that we can tune it to look at just the phenomenon on the surface that we're interested in. So for the United States' central region, for instance, we can look at agriculture and soil moisture. And so we're examining the differences in the moisture content of the breadbasket of the U.S. and the Great Plains from last April to the present. We're looking in the tropics and in the far northern hemisphere for changes in the forests around the world.
The payload bay cameras are taking pictures of the cloud cover and land masses of the Earth. Some beautiful pictures, too. Look at these. Forests in Michigan and in Europe, and deserts, including those in Africa and the Middle East. The astronauts are working 24 hours a day, taking pictures of the Earth and making sure the radar continues to operate. They report no problems with any of the equipment. One of the main goals of the mission is to monitor the Earth's environment. The shuttle has flown over Rwanda and Zaire to look at the gorillas of the mist, as I told you, and gorilla protectors say the pictures from space are helping them track the gorillas despite Rwanda's civil war. Mission managers say they're close to giving the crew another day in space, an extra day. John, you said they've got a 10-day mission here. They may get an 11-day mission. They've been saving electricity, and they'll learn on Thursday of this week whether they'll get to stay up one additional day.
Fascinating stuff. John Holman, thanks so much for being with us. Sure. The Russian space program is forging ahead as well. 3 cosmonauts, 2 of them Russians, 1 a German, blasted off more than 19 hours ago. Their goal, to link up with the 3-man crew aboard the space station Mir. The 2 Russians will swap positions with their colleagues already on board and remain in orbit until March. Then there's a scheduled joint mission with U.S. astronauts. Back on Earth in Geneva, scientists say the hole in the Earth's protective ozone layer over the Antarctic has gotten larger. The World Meteorological Organization says its measurements show a 65% drop in the ozone level since monitoring began a decade ago. The WMO says it expects ozone depletion to bottom out around the end of the 1990s.
Sprechen von 7,9 Punkten auf der Richterskala. In den USA wurden sogar 8,2 gemessen. Das Epizentrum lag im Meer östlich der Insel Hokkaido. Über Fernsehen und Rundfunk warnten die Behörden die Menschen in den Küstengebieten vor den gefürchteten Tsunami-Riesenwellen.
Eine erste Flutwelle erreichte noch am späten Abend die Küste Hokkaidos. Mit einer Höhe von 2 Metern war sie noch verhältnismäßig klein, aber die Behörden befürchten weitere Wellen, die vermutlich stärker sein würden. Die Bewohner wurden aufgefordert, sich auf höhere Küstenabschnitte zurückzuziehen. Das Beben war selbst im 1000 Kilometer entfernten Tokio zu spüren. Es dauerte über 1 Minute. Bisher gab es nur wenig Verletzte. Die meisten von ihnen hatten Schnittwunden von splitterndem Glas. Über die Höhe der Schäden liegen noch keine Informationen vor.
The launch of Space Shuttle Columbia, taking humankind to new frontiers of achievement. Among the crew, astronaut Sam Gaymar, a space veteran who spent more than 580 hours in orbit, a man pushing the edge of the envelope of a new technology as the sun sets behind the planet Earth.
Another million years back in time.
Now he's on another mission. Accompanied by fellow astronaut Winston Scott, Sam Gaymar takes a journey back to the very dawn of time. Under excavation from the rocks of Sterkfontein near Johannesburg are the remains of our earliest ancestors.
The fossils that are here represent the earliest species, the Australopithecines, the gracile Australopithecines, which represent that very nub, that missing link between the apes, the very advanced apes, and the very earliest of the human ancestors, of which these are.
Here are fossils dating back 2.6 billion years.
Here's a scapula and a humerus.
Next to them, the remains of man, estimated at some 2 million years old.
2 fossils which contain the entire history of life within a decimeter of each other.
And here, too, the earliest tool ever found, the beginning of technology.
What you're looking is the first change that separates all of humankind from the apes.
It's a very humbling experience. Right now, we have a space shuttle orbiting the globe right now. The one instrument the one radar is made up of some 50,000 components, some 50,000 electronic components in that one radar alone. But Dr. Berg's point is that it all started right here with this flaking of the rock, most primitive tools. And everything since then, evolved from that one basic tool.
Had it not been for the very beginnings, we wouldn't be where we are now. And if this is any indication of where we're going to in the future, meaning that we continue to evolve, then I think mankind is in good shape.
As the journey into the future continues in space, man on Earth continues delving into the past. On a hot African morning, as yet another fossil is painstakingly revealed, the meeting between space age and stone age produces a simple thought.
If you don't understand your past, you have no idea where you're headed, what your future holds.
Mike Hanna, CNN, at Sterkfontein, South Africa.
Vor der Küste von Sylt 500 Liter Öl in die Nordsee gekippt. Aus dem All fotografierten die Astronauten der Raumfähre Endeavour das ungewöhnliche Experiment. So wollen die Behörden künftig Umweltverschmutzer ermitteln. Denn pro Jahr werden rund 250 Millionen Liter Mineralöl illegal in die Nordsee abgelassen. Susanne Müller berichtet.
Der größte Ölteppich ist so groß wie 40 Fußballfelder. Insgesamt 8 solcher Ölfelder mit Diesel, Heizöl und Fischöl-ähnlichen Substanzen pumpten Schiffe heute in die Nordsee. 40 Kilometer vor Sylt breiteten sie sich aus. Im All überfliegt gleichzeitig die Endeavour das Meer. Ein neues Radargerät macht Bilder und schickt sie sofort zur Erde. Die Flecken sind zu unterscheiden. Das 250 Millionen Mark teure Experiment ist geglückt.
Das Ziel des Experimentes ist, Mineralölteppiche auf dem Meer eindeutig zu identifizieren.
Und so Ölsünder wie diesen besser aufzuspüren. 300 Millionen Liter lassen sie jedes Jahr allein in die Nordsee ab. Umweltschützer fordern deshalb eine bessere Ölentsorgung statt teurer Allüberwachung. Wenigstens heute wurde das Öl entsorgt. Fische und Vögel wurden nicht belastet.
Umweltsünder könnten künftig aus dem All verfolgt werden. Ein Experiment vor Sylt zeigte heute wie. Vor der Insel hatten Wissenschaftler insgesamt 8 verschiedene Substanzen in die Nordsee gekippt, darunter auch Heiz- und Dieselöl. Trotz dichter Wolkendecke wurden sie von einem Radar an Bord der amerikanischen Raumfähre Endeavour festgehalten. Die Substanzen waren auf dem Schirm als schwarze Flecken zu sehen. So kann man künftig natürliche Stoffe von Ölverschmutzungen durch Umweltsünder unterscheiden.
Heute Morgen um 9:12 Uhr und 45 Sekunden war es soweit. Die Raumfähre Endeavour überflog genau für 1 Sekunde das Testgebiet vor der Nordseeinsel Sylt. Zuvor hatten Wissenschaftler des Hamburger Institutes für Meereskunde gezielt das Meer verunreinigt. 400 Liter schweres Heizöl und 100 Liter Diesel flossen in die Nordsee. Das Ergebnis des Experimentes kann sich sehen lassen. Zum Erstaunen des Forschungsteams machte ein Radargerät an Bord der Endeavour erstaunlich gute Bilder. Die Ölflecken sind deutlich voneinander zu unterscheiden.
Das Ergebnis finde ich ganz super. Gestern Abend sah es ja nicht so gut aus. Eine Steuerdüse an Bord von Endeavour war ausgefallen und es war nicht klar, ob das Shuttle jetzt auf unseren Ölfleck auch wirklich genau ausgerichtet werden konnte.
Sofort nach dem Überflug haben Ölbekämpfungsschiffe den Ölteppich wieder aufgesaugt. Das gute Gelingen des Experimentes ermöglicht es in Zukunft vom Weltraum aus, Umweltsünder auf dem Meer besser ausfindig zu machen. Experten schätzen, dass jährlich rund 300 Millionen Liter Mineralöl illegal in die Nordsee geleitet werden.
Für so manchen Kapitän auf großer Fahrt ist es immer noch gängige Praxis. Auf offener See kommt alles, was weg muss, einfach über Bord. Sogar die Reste aus den Öltanks werden ins Meer abgelassen. Allein in die Nordsee gelangen illegal jedes Jahr 200 bis 300 Millionen Liter Altöl. Doch die Meeresverschmutzer müssen künftig damit rechnen, dass sie mit Argusaugen aus dem All beobachtet werden. Die Besatzung der amerikanischen Weltraumfähre Endeavour hat mit einem Superradar aus 225 Kilometern Höhe Ölteppiche in der Nordsee geortet. Und zwar genau das Öl, das Wissenschaftler kurz zuvor zu Testzwecken vor Sylt ins Wasser geschüttet hatten. Das erste Faxbild aus der Endeavour lässt zwar noch nicht viel erkennen, doch die Wissenschaftler versichern, das Radar könne sogar natürliche Substanzen, etwa Algen oder Plankton, von Öl unterscheiden. Ob und wann nun das erste Ökoradar ständig um die Erde kreist, steht allerdings noch in den Sternen. Übrigens, Die künstliche Ölpest vor Sylt haben die Wissenschaftler wieder beseitigt, wenn auch nur zu 80%.
In Zukunft wird es möglich sein, Meeresverschmutzer per Satellit vom All aus zu ermitteln. Bei einem NASA-Experiment vor der Insel Sylt gelang es der Raumfähre Endeavour, 6 Ölteppiche per Radar genau zu orten.
Das bislang einmalige Experiment hat die NASA in Zusammenarbeit mit deutschen Wissenschaftlern des Hamburger Instituts für Meereskunde gestartet. 20 Kilometer vor der Insel Sylt wurden 6 Ölteppiche insgesamt nur 500 Liter von Schiffen in die Nordsee eingebracht. Mittels eines Multifrequenzradars gelingt das Experiment. Die Raumfähre Endeavour ortet zur Freude der Wissenschaftler die Ölteppiche.
Genau um 9:12 Uhr und 46 Sekunden. Und sehr gut. 47,5 Minuten Nord, 747,9 Minuten Ost. IXA an Bord der amerikanischen Raumfähre Endeavour.
Derart allgegenwärtig überwacht wird es künftig möglich sein, Umweltsündern mit solchen Radarbildern das Handwerk zu legen. Allein in die Nordsee, so schätzen Experten, werden jährlich bis zu 300 Millionen Litern Mineralöl illegal eingeleitet. Lückenlos wird die Überwachung der Meeresverschmutzer allerdings wohl erst Ende dieses Jahrzehnts sein.
NASA launched Magellan to map the cloud-covered surface of our neighboring planet, its towering volcanoes and deep craters. During its 4-year mission in orbit, Magellan has mapped 98% of Venus's surface and collected detailed data on its gravity. Now, one of NASA's most successful missions is headed for a dramatic end. Controllers will steer the spacecraft on a collision course with Venus. As it plunges into the searing planet, NASA hopes to learn even more about spacecraft performance, aerodynamics, and Venus's thick atmosphere. As one space mission ends, another gets a new life. The orbiting space station Mir has some new crew members this week. 2 Russian cosmonauts and a German colleague rode into orbit Tuesday. After 2 failed attempts to dock their rocket with the space station, the crew succeeded on the 3rd try. One of the cosmonauts is a mother of 1 who hopes to stay in orbit for 6 months. That would be a record for a woman. By that time, she'll be expecting visitors from the United States space program. Next March, NASA plans to send a space shuttle up to dock with the Russian space station. After a short break, we'll see what's up with the current shuttle mission and explain how it relates to endangered gorillas in Africa. This week, the Air Force test-fired a Minuteman missile with a new guidance system. The 3-stage rocket blasted off the coast of California early Wednesday morning. The Air Force says it took 30 minutes for the Minuteman to hit its target some 4,000 miles away on the Marshall Islands. The crew aboard the Space Shuttle Endeavour was busy taking pictures of Earth this week. The shuttle's mission? To gather data and images on environmental conditions around the globe. A special radar system on board Endeavour penetrates clouds to reveal underlying vegetation and terrain. The radar looked at areas all around the globe. These images show regions of Africa where endangered mountain gorillas live. Researchers hope to use the radar data to create a detailed map of their habitat. In recent years, human beings have done little to protect the mountain home of those great apes. Researcher Diane Fossey, whose fight to protect the endangered creatures was depicted in the movie Gorillas in the Mist, was killed 9 years ago. More recently, the civil war in Rwanda left them under siege. But CNN's Gary Stryker says the gorillas may be just fine in spite of efforts to the contrary.
High above the human conflict in Rwanda, in the mountains of this national park, they could hear the gunfire and the explosions, and sometimes the screams of victims in the valleys below. Wanting no part of that violence, they retreated deeper into the safety of the forest, only recently returning to the lower slopes where the trackers can find them. About 600 mountain gorillas are still alive, half of them found in this small patch of rainforest on the borders between Rwanda, Uganda, and Zaire. Conservationists worked with the government to protect the gorillas, but during Rwanda's time of war and anarchy, research camps were destroyed, staff were evacuated, and the gorillas left to fend for themselves. So with an end to the upheaval in Rwanda, at least for now, park rangers and trackers who came back here are happy to find the gorillas apparently unharmed.
All the fighting was done just below the hills. Despite the fact that they were frightened by the gunshots, they were not at all affected by the fighting.
Some guerrilla groups have not yet been located. but not enough rangers have come back to mount a serious search. The gorillas are a major economic resource for Rwanda. Tourists come here and spend a lot of dollars to see them, and the new government appreciates that.
The government's policy is to protect those gorillas.
But to rebuild what was here before, the government and conservation groups will need money and continued peace. There's heavy military security in this area, and UN observers are watching closely.
From a military point of view, this area is probably ideal for infiltrating people back into Rwanda.
If former government soldiers or militiamen want to counterattack from refugee camps in neighboring Zaire, this is a likely place to do it. And even if peace continues, resettlement of hundreds of thousands of refugees and their livestock will cause more pressure on the boundaries of this park and the shrinking habitat of the gorillas. So while the good news is that the mountain gorillas have not so far been affected much by the human tragedy around them, there are ominous signs that the greatest threats to this park and to the gorillas could still lie ahead. Meanwhile, Diane Fossey's grave lies undisturbed at the research center she founded. After inspiring the world to protect mountain gorillas, she was killed mysteriously in 1985, amid widespread suspicions that powerful government figures were responsible. A spokesman tells CNN the new government will consider reopening the investigation into Fossey's murder. Gary Stryker, CNN, Parc National des Volcans, Rwanda.
A powerful earthquake rocked Hokkaido Island of northern Japan and the nearby Kuril Islands on Tuesday. The quake registered 7.9 on the Richter scale as it rattled buildings and split roadways into pieces. Aftershocks continued to shake the areas for days. Because the quake was centered in the Pacific Ocean, many feared that huge tsunamis or tidal waves would strike areas as far away as Hawaii, but none did. On the other side of the Pacific, people who live in the shadow of Washington's Mount Rainier are wondering when that big volcano is due for an eruption. It last blew 150 years ago. Researchers are doing their homework trying to make a prediction. But as Craig Heaps explains, volcanology is not an exact science.
Only 50 miles southwest of Seattle, Mount Rainier's stunning beauty hides the danger that lies below its surface. The tallest volcano in the Cascade Range, it last erupted 150 years ago. But how soon will it erupt again?
We don't know. It could be within our lifetime. It could be within several lifetimes.
Sisson and other geologists are looking for that very answer. As part of a United Nations project that has targeted 14 volcanoes in 12 nations, they study the history of Mount Rainier's eruptions by examining the volcanic rock that covers its surface. At the U.S. Geological Survey Lab in Menlo Park, California, they date the samples and search for answers.
How has the volcano behaved in the past? What kinds of lava has it produced? How thick are they? How hot were they?
2.5 million people live in the big cities and small towns around the volcano. Mount Rainier sits only 45 miles north of Mount St. Helens, which erupted in 1980, killing more than 50 people. Unlike Mount St. Helens, Rainier will probably not spew a choking cloud of ash. Rather, geologists say, the heat escaping from its crater could melt the massive glacier that caps its peak. That would trigger flooding, perhaps as far away as Tacoma, 30 miles to the northwest, and massive mudslides in the valleys leading to the mountain. In 1985, 23,000 people died when Colombia's Nevada del Ruiz volcano set off a mudslide that buried the town of Amero. Unaware of the volcano's history, officials had allowed the town to be built on the mud flows from earlier eruptions. But officials in the Philippines knew the history of Mount Pinatubo and were able to evacuate 200,000 people from the path of mudslides when it erupted in 1991. Emergency managers in Washington state discourage building on old mudslides and have begun to formulate evacuation plans, but sometimes find it's difficult to convince people they live in the valley of the shadow of death.
From the experiences of Mount St. Helens, it can be taken seriously, but one of the difficult things in emergency management is events that could come from Mount Rainier that could be extremely catastrophic, but have a very, very, very low probability of occurrence.
Geologists say Mount Rainier will likely give off weeks or months of warning before it blows, and that should give them time to convince most any doubter. Craig Heaps for CNN, Mount Rainier, Washington.
The Space Shuttle Endeavour is on a precedent-setting mission. Astronauts are creating detailed maps they hope will one day help predict earthquakes and volcanic eruptions. NASA is attempting to direct the shuttle over the exact same spot for 2 consecutive days. This allows Endeavour's powerful radar to scan the same area from slightly different angles and detect minute changes in the Earth's surface. If NASA can globally monitor earthquake faults and volcanoes, it could lead to an early warning system.
Endeavour soll einen Tag länger im All bleiben als vorgesehen. Der Grund, die Radarvermessung der Erdoberfläche verläuft unerwartet erfolgreich und soll fortgesetzt werden. Mithilfe der Messdaten können Computergrafiken erstellt werden, hier ein Gebirge an der amerikanischen Ostküste. Sie sind präzise genug, um an der Erdoberfläche Bewegungen von wenigen Zentimetern nachzuweisen und eines Tages Erdbeben und Vulkanausbrüche vorherzusagen. Auch die europäische Ariane fliegt weiter auf Erfolgskurs. Von Kourou in Französisch-Guyana aus startete in der Nacht bereits die 38. Trägerrakete dieses Typs. Bereits nach einer halben Stunde war die Mission planmäßig beendet. Die Ariane trennte sich von ihrer Fracht, einem mexikanischen und einem thailändischen Telekommunikationssatelliten.
Heute früh 2 Satelliten im All ausgesetzt. Nach dem Start vom Raumfahrtzentrum Kourou in Französisch-Guyana trennte sie sich in 200 Kilometer Höhe von dem mexikanischen Satelliten Solidaridad 2. 5 Minuten später wurde ein thailändischer Satellit ausgesetzt. Es war die 68. erfolgreiche Weltraummission der Ariane.
The 68th Ariane rocket blasted into space late Friday, lighting up the sky over French Guiana. After its textbook launch, the rocket placed satellites into the orbit for Mexico and Thailand. The 2 satellites will provide voice, video, and data communications. This was the 5th successful flight since January, when a failure plunged satellites worth $300 million into the ocean.
From 175 kilometers above the Earth, the crew of the U.S. Space Shuttle Endeavour has been scanning the Australian outback and other areas with powerful radar. The images will be used to create extremely detailed maps, which might one day be used to predict earthquakes and volcanic eruptions. NASA is rescanning some areas so the radar can detect minute changes in the terrain over a 24-hour period. The mission of the Endeavour is scheduled to end on Tuesday. Meantime, the 68th Ariane rocket blasted into space late Friday, lighting up the sky over French Guiana.
Ignition and liftoff.
After its fiery but faultless launch, the rocket placed satellites into orbit for Mexico and Thailand. The 2 satellites are to provide voice, video, and data communications. It was the 5th successful flight since January, when a failure plunged satellites worth $300 million into the ocean. The president of Ariane Space says the company now has orders for 38 more launches, valued at more than $3 billion. For weather news here on Earth, we turn now to CNN's Doug Hannon.
Now turning more towards the north, heavy rains likely over much of Taiwan and some hurricane-force winds. It looks like the eye of the storm, or the center, will pass just east of the islands. That will keep the strongest winds offshore. Still, though, there could be some problems over that area. Let's quick look at your weather. A complete forecast is coming up within the hour.
Extremely accurate topographical maps and to help scientists predict earthquakes and volcanic eruptions. Researchers say similar radar aboard permanently orbiting satellites will help them detect even tiny changes in terrain in earthquake fault zones. The Endeavour made its rerun over Australia, gathering 3-dimensional images there. It hit in the late afternoon off Hokkaido and was felt as far away as the Kuriil Islands. The epicenter was 130 kilometers east of Hokkaido. Sunday's tremor is an aftershock of Tuesday's earthquake in the same area. Tidal wave warnings have been canceled now. So far, there are no reports of serious damage or injuries. Advantage of a bonus day in space to continue radar mapping of the Earth. On Monday, they turned their sights on ocean currents near the Antarctic Circle and on forests in the U.S. state of North Carolina. The shuttle was originally scheduled to land in Florida on Monday, but onboard energy conservation by the 6 astronauts earned them an extra day in orbit. The shuttle's sophisticated radar system has now gathered more than 80 kilometers of videotape to be used for making highly accurate maps of the planet Earth.
We put together the images from last April and October over Long Valley, California, an old volcanic crater in California, to make this three-dimensional topographic map, the whole objective of this interferometry experiment. And this is digital topography made from the radar without any contour elevations from the ground. Now, the radar was cooking throughout the whole 10 or 11 days of science, but eventually we started to run out of film. Here it is piling up, exposed in our storage bags on board. And when we ran down out of film, the radar was also running down its investigations. There's Mike and Jeff waving goodbye from the crew. And while the sun was setting on SRL-2, we were also getting ourselves set up to come back for entry day, hopefully to Florida, but we wound up in California.
As you can see, we've turned our orbiting laboratory into a re-entry vehicle and also an airplane. Jeff, on the right there's a shot towards Bakes. You see out the window the glow of the atmosphere as we start to re-enter, and the hot plasma gases as they come over the orbiter periodically meet overhead and cause bright flashes. There's looking over Terry's shoulder on the right-hand side, the pilot, and you see sunset there, and there's Bakes flying.
At this point, we take over manually at about 50,000 feet overhead the runway and fly it around the heading alignment cone. And here you see us turning on the final just prior to doing our subsonic DTO, or flight test. There's a little wind, which is about all the motion that you see out of the aileron doublet and yaw doublet that we did. We're coming down 18-degree glide path at 300 knots. At 2,000 feet, we performed the pre-flare. Our glide path to about 1.5 degrees. At 300 feet, Terry put the gear down. And we crossed the threshold at about 200 knots and 35 feet. Looking for a touchdown about 200. We touched down at 195, about 1 foot per second on the sync rate. And we were also doing the drag chute flight test, so we put the chute out immediately on main gear touchdown, allowed it to fully deploy. From touchdown to the start of derotation was about 15 knots. Started the derotation, got the nose around about 130 knots. Started braking about 80 knots, and at 60 knots, you'll see in a second, we'll jettison the chute, and came to a stop about 12,000 feet down the runway with 3,000 feet remaining.
And Washington's ambassador to the UN, Madeleine Albright, says at best she considers the Iraqi troop movements ambiguous and does not accept Baghdad's claim that a withdrawal is underway. Now for the latest update on the situation, we go to CNN's Wolf Blitzer at the White House. Wolf, what can you tell us?
Well, Sonia, here at the White House, the president's top national security advisors will be meeting this afternoon to review the latest developments in Iraq. Under consideration are two military options, one which would include a preemptive strike against Iraqi troops in southern Iraq, and the second would be forcing Iraq to accept a ground equivalent, if you will, of the no-fly zone, something that is being described as a buffer zone along the border with Kuwait elsewhere in southern Iraq, in which the Iraqis would not be allowed to deploy heavy armor or other advanced weaponry, and in which they would not be allowed to go, so that another crisis along these same lines would not be allowed to develop in the coming months. No final decisions on those 2 points, but if in fact the U.S. does force Iraq, or at least attempt to force Iraq into accepting this new buffer zone in the southern part of Iraq, it would raise the ante dramatically. Unclear how Saddam Hussein would respond. Presumably he would reject it as a violation of his sovereignty, unless there is some easing of the international sanctions that have been imposed against Iraq over these past 3.5 years. And here at the White House, there is absolutely no desire at this point to ease those sanctions whatsoever. So the situation remains tense. President Clinton is on the road on a political trip to Detroit today. Earlier, he left the White House. When he left the White House, he did issue a strong statement insisting the Iraqis had not yet ended their threatening posture. Sonia?
Main gear touchdown.
And so the Space Shuttle Endeavour was back on Earth, not the exact spot on Earth, though, that NASA had first planned for. Thick clouds over the central coast of Florida called NASA to reroute the landing out to California's Edwards Air Force Base. The 6-person crew had spent 11 days in orbit on a largely environmental research mission.
Ist nach 11 Tagen in Kalifornien gelandet. Die 6 Astronauten haben präzise Aufnahmen zur Umweltüberwachung gemacht. Teil der Mission war auch ein umstrittenes Experiment mit einem absichtlich ausgelegten Ölteppich vor der Nordseeinsel Sylt.
Allerdings musste die Crew wegen des schlechten Wetters auf dem Luftwaffenstützpunkt Edwards in Kalifornien umgeleitet werden. Die Besatzung der Endeavour hat ihre Mission, die Kartografierung der Erde, mit einem Weltraumradar erfolgreich erfüllt. Ziel des Experiments war es, auch minimalste Unterschiede auf der Erdoberfläche zu erfassen. So sollen Umweltkatastrophen wie Erdbeben oder Vulkanausbrüche rechtzeitig vorhergesagt werden können.
And nose gear touchdown.
From the Kennedy Space Center in Florida, this is Space Shuttle Endeavour Launch Control. The countdown for the launch of Endeavour on Space Shuttle mission STS-68 is continuing on schedule this morning. Again, the final inspection team is continuing to conduct their final portions of the work at the pad, and they will be departing the pad shortly to make their final report to the launch director. No issues have come up in the wake of their assessments, and everything continues to look good. As the crew completes their breakfast, they will soon be donning their flight suits and entry suits, and the commander and pilot will be given a final briefing on today's weather outlook. Starting with our commander, Mike Baker. All are being assisted with their suits by Kennedy Space Center and Johnson Space Center technicians. These personnel are experts in the understanding of the details on how these suits work. Pilot today is Terry Wilcutt. He'll be making his first trip into space on Shuttle Endeavour. Mission specialist Steve Smith is making his first trip into space today also. He appears ready to fly, ready to go up. The bright orange colored suits are basically an altitude protection system. And of course they're checked out prior to launch. Payload commander Tom Jones making his second trip into space. His first trip was just this past April. Mission specialist Jeff Weissoff making his second trip into space today. And mission specialist Dan Birch making his second trip into space today. Making preparations on his suit to make sure that it pressurizes as it should. Checking all the straps and loops. Following launch and while on orbit, the crew members change out of these suits into more conventional and comfortable clothing. However, they are required to return to these suits prior to landing. This is Shuttle Launch Control. We are now at T-minus 3 hours and counting. Everything continues to look good for our launch this morning at 7:16 a.m. from pad 39A. With the Space Shuttle Endeavour on mission STS-68. This is Shuttle Launch Control at T-minus 2 hours, 50 minutes and counting, and we have our 6-member crew on the 3rd floor of the Operations and Checkout building. They have been suited and they're ready to take that 20-minute trip out to the pad. Getting on the elevator, they'll be going down to the 1st floor, at which time they'll be entering the crew Astro van. And our crew are walking out of the Operations Checkout building on their way to pad 39A. Mike Baker, pilot Terry Wilcutt, and mission specialist Tom Jones, Jeff Weissoff, Steve Smith, and Dan Bush. This is Shuttle Launch Control at T-minus 2 hours, 34 minutes and counting. And the Astro van with the astronaut crew members inside has arrived at the base of pad 39A. And they are at this time disembarking from the astronaut van. And once they're all gathered in the elevator, they'll make the trip up to the 195-foot level of the fixed service structure and begin their ingress into the orbiter. Pad 39A is the southernmost pad of NASA's 2 shuttle launch facilities, and it is nearly identical to Pad 39B, which is located just about a mile to the north. It looks like our crew members have deviated a little bit from their desire to go straight up to the orbiter, and they're going to stand beneath the mobile launcher platform and have a quick picture taken of them. And we are at T-minus 9 minutes and holding. And all of our sights are observe go and forecast go as far as weather is concerned. We're just a few seconds away from resuming the countdown for the launch of Space Shuttle Endeavour this morning.
On my mark. 3, 2, 1, mark.
And we're at T-minus 9 minutes and counting.
Auto sequence has been initiated.
And the ground launch sequencer has been initiated. NASA Test Director Bill Dowdell is about to call for the transmittal of stored pre-launch commands. As Endeavour is only 9 minutes from its 7th mission in space, on board is the Space Radar Laboratory and a crew of 6 astronauts. T-minus 7 minutes, 30 seconds, and the orbiter access arm is now being retracted away from the vehicle. This is the walkway used by the crew to gain entry into and out of the vehicle and can be returned to position within seconds if need be. And final aero surface checks of the orbiter's flaps and rudder are being completed. This verifies the orbiter's hydraulic systems. And the 3 main engines are being gimbaled as a final test before launch. T-minus 2 minutes, 30 seconds.
No unexpected error, so that's complete. Copy that.
All is ready to fly today on NASA's 4.5 million pound space shuttle vehicle.
TC, close and lock your visors and initiate O2 flow. This time we're going to get you airborne. Good luck, gentlemen. That'll work, thanks. See you in 10 days. PLS is go for ET LH2 pressurization.
T-minus 1 minute, 50 seconds. Everything continues to look good for launch this morning as the Space Shuttle Endeavour soon will begin its 10-day mission to continue its radar mapping expedition and study environmental changes on Earth.
PLS is go for auto sequence.
And we have a go for auto sequence start. Endeavour's onboard computers have primary control of all the vehicle's critical functions. T-minus 20 seconds. 15, 12, 11, 10, 9, 8, 7. We have a go for main engine start. 4, 3, 2, 1. And liftoff of the Space Shuttle Endeavour on a mission to study the Earth's ever-changing environment.
Houston now controlling.
Houston Endeavour, roll program.
Roger, roll, Endeavour. Endeavour's roll maneuver is underway. Vehicle's now in a heads-down position on course for a 57-degree, 120 nautical mile orbit. Approaching 2 minutes into the flight, the next event is burnout and separation of the solid rocket boosters. SRB separation is confirmed. Endeavour's altitude is 170,000 feet. Downrange from the launch site, 32 nautical miles. Now traveling 4,400 feet per second, or about 3,000 miles per hour. Three and a half minutes now into Endeavour's mission. The orbiter is downrange from the launch site, 91 nautical miles, traveling 4,400 miles per hour at an altitude of 306,000 feet.
Endeavour Houston, we see a nominal MECO, OHMS 1 not required.
Roger, nominal MECO, OHMS 1 not required.
This is Mission Control Houston. We're now receiving some videotape from the Space Shuttle Endeavour of the external tank as it drifts away from the Shuttle Endeavour, following today's 6:16 a.m. Central Time launch from Kennedy Space Center. This tape being sent down to us through the Merritt Island Tracking Station on the coast of Florida.
That's complete. Copy, thank you. Liftoff confirmed. Copy. Houston Endeavour, roll program.
Roger, roll, Endeavour.
In flight guidance, we see the roll.
Copy, guidance. Throttle up 3 at 104. Copy. Endeavour, go at throttle up.
Roger, go at throttle up.
SRB set. Copy, SRB set.
103 converged.
Single engine press 104. Endeavour, single engine press 104.
Single engine press 104. For T, we have 5.999er. And for the fuzzy logic error, we have all balls. How copy?
And Endeavour Houston, we copy all. Thanks.
Good, Mario, and I've moved to block 12. The answer to block 12 is no, I have not disabled the messages. I'll stand by for block 13 with your go.
All right, we copy. Let's look at it.
Now let's talk about the first of the two experiments. The first experiment is called BRIC. It's Biological Research in Canisters. And it's sponsored by the United States Department of Agriculture. There are 5 canisters, aluminum canisters like this on board. Within each canister there are 1,000 gypsy moth eggs. So we have 5,000 gypsy moth eggs flying with us here on Endeavour. Now you might ask, why do we have gypsy moth eggs on Endeavour? It turns out that the gypsy moth is a very destructive pest in the United States, especially to northeast hardwood forests. So the United States Department of Agriculture has a goal of controlling the population of gypsy moths in that area. Now the way they control gypsy moth population is by introducing sterile gypsy moths into the wild. They've tried to produce sterile gypsy moths on the ground, but it's a very difficult process and also very time-consuming. We also don't know exactly the mechanism within the gypsy moths that makes them sterile, but we do have a ground process that works. Well, by accident, we have actually found out that gypsy moth eggs, if they are carried in spaceflight, produce sterile gypsy moths. We don't quite understand the mechanism, and that's the goal of this experiment. If we take these 5,000 gypsy moth eggs with us and give them back to the USDA after the flight, they should produce sterile gypsy moths. And the USDA will be able to look at those gypsy moths and understand the exact mechanism that creates their sterility. Now, they wouldn't want us to grow sterile gypsy moths in space for introduction to the wild in mass populations, but they would like to understand the mechanism that creates sterility and hopefully reproduce it on the ground. So there's one example how going away from the Earth's surface actually can be used to solve a problem we have on Earth. So that's the first of the two experiments. The second experiment I'd like to discuss with you today is called the Commercial Protein Crystal Growth Experiment, or CPCG, and it's sponsored by the University of Alabama. Now, before I get into the details, let me tell you that the goal of this experiment, it's flown 32 times on the shuttle, by the way, is to either create new drugs or to improve drugs we already have. Now, drug design in the United States now is based on a sophisticated process called structural-based drug design. That's where experimenters, rather than taking a sample of a disease and applying different drugs to it in a somewhat haphazard way, actually study the disease's structure, study the drugs that they might consider would solve that disease, so they just fit together. So they actually look at the structure of this crystal or drug to try and find out what exactly fits into that disease that actually would cure that disease. Now, the National Institute of Health has named structural-based drug design as one of their #1 priorities in the next 10 years. Now, unfortunately, in some cases where we grow crystals on the ground, again, trying to analyze the crystals to heal this disease, the crystals cannot be grown on the ground because of gravity. Well, the good news is that in space, we don't have gravity, and we can grow crystals for the scientists. Okay, what I have here is a picture on the bottom of a ground-based crystal grown. And on the top is a crystal grown in space. Now, these photos are the same magnification of the same drug. So you can see that these crystals on the ground, grown on the ground, were limited in size and quality, whereas the crystals grown in space are much bigger and much better quality. Therefore, spaceflight produces crystals that are better quality and larger. Scientists can then take the crystals on the ground and analyze them. Now, on our flight, we're flying something called alpha interferon. It's already a very successful drug around the world, used in 60 countries to treat various forms of cancer and also viral diseases. However, remember that the goal of CPCG is either to help discover new drugs or to improve current drugs. And in our case, we're trying to improve alpha interferon. And when you try to improve a drug, you're basically trying to eliminate some of the side effects. So now, that's the second experiment I've described to you. And it's an excellent example of how we go into space to improve our lives on Earth and to solve problems we have on Earth. So when you think of NASA and the shuttle program going up into space, we go away from the Earth's surface to actually help our families and friends in the world on the ground.
done is from the middle.
Yeah, just remember this is one.
Endeavour Houston, at this point we'd like to future load block 136. So you understand, we optimized for the Southern Ocean data take.
Good point, Jeff, thanks. Okay. Flip the road switch, I'm doing that, I'm pushing that, I'm horizontal head calibration trial number 2. Go right to the green center, left to the green center. Release, good, okay.
I'll pan over here and show the target too. So that they can...
Okay, horizontal head calibration trial number 2.
Oh, you can see the little dot on there.
Endeavour Houston.
Houston.
Okay, horizontal head calibration trial number 3.
We'd like to take a look at the function of the pilot side panel trim enable switch. Flip it up to enable and then back to inhibit for us, please. And Mario, a little bit more about one of the medical experiments we're participating in. You may have noticed the device that's on Dan and my wrists. It's called the Actilume, and it's part of the DSO 484 that Lactucha is sponsoring. And not only are they monitoring the melatonin levels in our urine and saliva, they're also monitoring the light levels that we're exposed to. Light apparently controls the production of melatonin. So the devices that we have on our wrists are actually measuring the light levels that we're exposed to 24 hours a day. In addition to measuring our levels of activity, there's some accelerometers in these devices, and so it measures our level of activity during the day, and they're particularly interested in the level of activity while we're sleeping. It can tell them whether we're sleeping very well or not, and therefore that's a good measure of how well we're adjusting our time clocks.
Pretty much count on looking at the imagery after the mission. We don't have ready access to NASA Select, but we're very excited about the work that you're doing, and we'll be looking forward to seeing you after you get back to Mother Earth.
time limit. There's lots of interesting features to stick away from.
And burn some of their circuit boards. Thermal fuse open. I've never heard of that. It's not even on here. Oh, there it is. Check.
Oh, sorry.
Keep going.
We have a few minutes here at the end of the shift where I'd like to tell you about our activities on board, tell you about the major components of the Space Radar Laboratory, talk about our science goals for the week's activities, and tell you about some of the examples of global change that we look forward to sharing with the people and the scientists back on Earth. This Space Radar Lab 2 is part of NASA's mission to Planet Earth. That's a program that NASA's conducting to look at Earth's life, land, water, the air around the planet, and all the interactions of those components. We're trying to understand Earth as a single complex system so that we can get a handle on the real numbers behind the changes our globe is experiencing. Now, the Space Radar Lab goal as a part of Mission to Planet Earth is to look for those hard numbers on Earth's changes, both man-made and natural, and try to bring those back to Earth so we can understand how we're affecting the planet and how we have to cope with those changes. Now, to do that, we have a payload bay full of sophisticated instruments that last flew in April on STS-69, and I'd like to tell you a bit about those, and I've got a little video segment here to show you those components. The first component we have on board Space Radar Lab is a state-of-the-art imaging radar, and we're going to show you here in this view as we come down from the overhead windows our Cersei XR radar out in the payload bay. The other component of SRL is the MAPS air pollution sensor, and in this view of the payload bay you can see the large radar array stretching from about the forward end of the bay all the way back to the tail. It's labeled JPL, that's the Cersei XR instrument. The Langley Research Center logo is on the MAPS instrument just to the right of the screen, to the left of the Canadian arm. And the small segment of antenna labeled XR is the German-built component of Space Radar Lab. Now, these sensors in the cargo bay aren't very useful unless we have the crew here on board to operate them. For the imaging radar part of the mission, the crew has an essential role to play. There's a huge amount of data coming down from the instrument out there as it images the Earth's surface, and those images have to be transferred to the ground. We don't have enough communications link on board to transfer them all in real time. So the first role of the crew is to handle the data coming back from the radar, and we do that by changing out our data tapes on board. We have about 207 data tapes on board. Each of them holds 50 gigabytes of data, and we've gotten very good at practicing changing out those tapes. We hope to bring back about 52 terabits of data, something like 20,000 encyclopedia volumes of information by the time we're finished. The second part of the crew's role is to handle the photography that supports the science investigations around the world. In many regions of the world, we don't have scientific teams on the ground to validate the results from the radar or from the MAPS pollution sensor. And so we are the ground truth. Our photography, some 14,000 still photo frames, is going to be used to provide the environmental conditions over those targets in remote areas of the globe where we don't have independent verification. And the last thing we're doing, and probably the most important role that the crew's playing on this mission, is to point the payload bay instruments at the required targets. And to do that, we're conducting a succession of maneuvers, about 409 of them during the mission. And that's about 25,000 computer keystrokes to tell Endeavour's computers how to orient the payload bay so as to get the optimum data coming back down to the ground. Now, the radar out in the cargo bay, Cersei XR, is a synthetic aperture radar, and it paints a picture of the Earth's surface through darkness and clouds and can thus operate around the clock all the way around our orbits every 90 minutes around the globe. The MAPS pollution sensor is an infrared spectrometer, and it measures the amount of heat radiation coming up from the ground and converts that into information on how much carbon monoxide is lying just beneath the space shuttle as we go around the planet. And over a couple of days, we can construct a map of pollution sources and the way the CO is moving around the world on a day-to-day basis. And this is a very good comparison with information we got last spring and on 2 previous flights of MAPS. And this is just the key to our whole mission, just looking for changes around the world. We're looking for changes since last April's STS-69 mission, Space Radar Lab 1. We're looking for changes in the previous MAPS data over the last 10 years. And these 2 flights and other flights in NASA's mission to Planet Earth will show the ability to monitor the Earth as a global system on a permanent basis. We're looking for changes like ecology changes around the world, climate changes, and some dramatic changes on the surface that we're more familiar with, like volcanoes and storm systems, for example. In the area of ecology, we're looking at clearing and deforestation around the world, looking at the tropical and northern forests of the world to see the rate at which we're destroying the forests and the rate at which they're renewing themselves, so we can really quantify that important phenomenon in the ecosystem. We've already seen a lot of forest fires over in Asia and in Australia, some at night over Africa and in South America as well. And our data, when we come back, will give us the rates of forest change around the world. In terms of pollution, we're looking for the way that carbon monoxide drifts around the world from its sources like forest fires and that will help us track seasonal pollution and also tell us what the most important sources are in various seasons, whether it's natural burning from forest fires or industrial sources like cities and automobiles. We're looking for climate change by looking at the geology around the world for traces in the geologic past of rainier and drier periods in the Earth's deserts and the valleys that show alluvial fan erosion. Those are very key points to investigate for looking back into the Earth's climatic past. And of course, some of the most dramatic things we're seeing in terms of change have been the volcanic eruptions up in Kamchatka yesterday and the day before. And we've also been looking at several storm systems down in the Southern Ocean that we can track on a day-to-day basis. And there are targets for both the radar and some of the MAPS instruments because those storm systems can distribute pollution around the world. We have a busy week ahead of us here on Space Radar Lab. We've got a lot of work to do in terms of maneuvering, changing the tapes, and most important for us on a daily basis is taking all those still photos from the aft windows. It keeps us constantly busy when there's a daylight pass going on. That's not surprising. The Earth is a very complex system. It takes a lot of study to understand it, and only a future permanent platform or a suite of instruments in orbit is going to be able to do that on a permanent basis. And we hope that by flying this test bed, we'll prove that that principle will in fact work. We're getting a taste of some of the exciting results that we're anticipating here in orbit with our own eyes, and it's going to be an exciting look at the data when we get back to the ground with those 207 data tapes and really see in full fidelity what the CERSI XR and MAP sensors have brought back. But we can see the changes here, and we're going to try to share them with you in the coming week. Okay, Houston, you should be getting this view of the Klutskoye volcano. You can see the snow-capped upper slopes, and then there's a very active eruption going on from the northeast portion of the mountain. Bezumiani is behind the smoke plume. It looks like from the shadow height, you can even estimate the height of the eruption plume, but we're guessing at least 35 or 40,000 feet. And that dark gray dust plume goes downwind at least 500 kilometers, if not more. Okay, now this is a going away shot, Houston, of the volcano. You can still see the lava flows at the top of the screen where the eruption's actually originating. And this gives you a good view of the profile of the plume. And there's another wide shot that Dan took starting just now that shows you the extent of the ash plume.
This is Mission Control Houston. We are receiving some data from the Space Radar Laboratory instruments. This particular data is coming down real time, or near real time, and is data as of the Kamchatka Peninsula. The orbiter is flying over this peninsula that is to the east of Russia and on the western side of the Bering Sea.
Houston Endeavour, you should be getting that video now.
That's firm, Dan. It's once again really just a fantastic video image.
From the synthetic aperture radar instrument on board Endeavour as it passes over the Rako, Michigan supersite. These are live pictures from the XR instrument. Rako, Michigan is one of the ecology sites being studied.
The ground looks just like it did then. We have a beautiful mosaic of fall colors beginning to develop, and you should be beginning to see lots of reds and yellows as you look down over our site in the days to come. You know, last night...
We'll certainly be looking for it. The lighting so far has made it a little hard to distinguish colors, but we have noticed a little bit greener inland and near the coastal lines of the Great Lakes. It's looked a little bit more fall-like.
that should be proceeding along rather quickly now. We've had 2 nights of good hard frosts with clear weather and the drying, so fall is coming quickly upon us.
And Endeavour's now moving across the northwestern portions of Africa. Again, using the synthetic aperture radar, it's very evident that the orbiter is now crossing over land. This is a geological site, a super site again, over the Sahara Desert area. The Sahara is an area which is about the size of the United States. Prior to its becoming a desert area, it had been apparently well laden with fairly major drainage networks. With increasing dominance of the wind and the sands and the channels and the various floodplains of the rivers began to be reworked into thin sheets and eventual scattered dunes.
This is Mission Control Houston. We're now receiving some additional real-time downlink from the synthetic aperture radar instrument in Endeavour's payload bay as it flies 118 nautical miles over the coast of Japan. With us again is Dr. Jeffrey Plout, the geology representative for Circe XR. Dr. Plout, what are we looking for in these XR images?
Well, at this point, we're traveling over the Sea of Japan, and this is an inland body, not an inland body. This is the strait between the main continent of Asia and Japan. And we will be coming up shortly on the Sarobetsu test site, which is the northern tip of the island of Hokkaido, which was the vicinity of the offshore earthquake earlier today.
Dr. Platt, is there any possibility we'll see any change in the shoreline because of the waves that have been in the area?
That is the type of observation that we would be interested in making, and in this case, perhaps looking for ponded water or any bright returns, bright radar returns from the nearshore area. Here we're coming over the southwest corner, and then beyond, in the top of the screen there, is the northeast section of the island, and there's no obvious evidence of damage, but this is going by rather fast, and we'd certainly need more time to sit down and do a detailed processing and analysis of the image.
And the next data take underway with the synthetic aperture radar in Endeavour's payload bay as the orbiter tracks northeast now, approaching the Great Lakes region. The Rako, Michigan super site is located on the eastern end of Michigan's Upper Peninsula. The particular site of interest is located between forested regions and the northern temperate forest, which is known as a transitional zone that is expected to be ecologically sensitive to global changes. The baseline studies are of the vegetation areas, and those areas are essential for being studied in monitoring the global changes. Again, the orbiter is tracking along the Great Lakes area to the northeast.
Coming up, here's the shoreline of one of the islands. And we can clearly see the volcanoes on those islands. These are some of the most remote volcanoes in the world and some of the least studies because of their remoteness and the difficulty of getting to them. In addition, this area is often cloud covered and makes it difficult for aerial observations or satellite observations.
Once we get the radar set up and ready to go, it's ready to start taking data. And the next scene that you're going to see is a picture of us passing over the Sahara Desert. As you can see that to the eye, it doesn't look very like there are many features, but when you turn the radar on, this is what the radar can see underneath the ground are ancient riverbeds. And that was part of our study. This was a geological site that we wanted to understand the history of how the Sahara Desert became what it is today, because obviously its climate in the past must have been very different to have these riverbeds underneath.
Now we were looking.
Is it cloud covered at all, Dan?
Say again?
Is it open, wide open?
It's wide open. Yeah.
Oh, great.
That stop's going to be 5.6. 5.6. Oh, man, you should. It's almost directly right overhead. I see it. I see it. I see it.
This is Mission Control. Houston Endeavour's tracking across the northeast portions of North America just to move off the coastline just to the north of Newfoundland. Views coming from the payload bay cameras aboard the orbiter.
It's, I see where it is. It's, you see the pincers, and there's kind of like a little gradual bend. It's after that gradual bend with a little harbor there. Yep.
Is it cloud covered at all, Dan?
Say again?
Is it open, wide open?
It's wide open. Yeah.
Oh, great.
That stop's going to be 5.6. 5.6. Oh man, you should. It's told us directly right overhead. I see it. I see it. I see it.
Go ahead.
Give 5 feet, 4 feet, 3 feet, 2 feet, stop.
Endeavour Houston, you have a go to maneuver to the comm attitude now.
Okay, Dan, we're waiting for 15 seconds and the flash will execute.
Looks like you should have come 68 seconds.
Right. Camper's getting heavy.
60 knots jettison. Shoots away.
40 knots of easy braking down. Good job. 20 knots of easy braking. Super jump.
Yeah, all right.
All right. Houston Endeavour wheel stop.
Endeavour on energy at the 90.
Roger.
Approaching 1,000 feet. And the landing gear is now down and locked. Main gear touchdown. And nose gear touchdown. Endeavour rolling out on runway 22 at the Edwards Air Force Base facility in California after 183 orbits of the Earth, traveling 4,703,000 miles.
Houston, Endeavour, wheel stop.
Roger, wheel step, Endeavour, and welcome home. Bakes, you and your crew have done a great job and made a significant contribution to the mission to planet Earth. We on the ground are proud of your work and proud to be a part of this flight. Well done.
The vessel's open. Ground speed enable auto load release. Copy.
Roger, wheel step, Endeavour, and welcome home. Bakes, you and your crew have done a great job and made a significant contribution to the mission to planet Earth. We on the ground are proud of your work and proud to be a part of this flight. Well done.
Thank you very much, Houston.
No Delta's flight.
Copy. No post-landing Deltas. We'll pick up with Convoy Commander Endeavour. How do you read?